everyone, welcome in my YouTube video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. This is third session of Engineering Curves chapter. In this session, we are going to learn common method for construction of ellipse, parabola and hyperbola, which is directrix focus method. So first let us understand definition of ellipse, parabola and hyperbola according to directrix focus method. Now what is ellipse? The ellipse is a locus of point which move in a plane so that the ratio of its distance from fixed point which is focus to fixed straight line which is directrix is constant and less than 1. The ratio is called eccentricity and eccentricity E less than 1. Let us understand this definition in one figure. Here, directrix straight line is given, horizontal axis is given which is perpendicular to directrix, ellipse given, this is focus point of ellipse and this is vertex point of ellipse. Now as per definition, ellipse is a locus of point which move in a plane so that the ratio of its distance from fixed point to fixed straight line is constant and less than 1. So this ratio constant at any position on the curve. Next, let us understand parabola. Parabola is a locus of point which move in a plane so that the ratio of its distance from fixed point to fixed straight line is constant and equal. So here the ratio is called eccentricity and in case of parabola, eccentricity E is equal to 1. Let us understand this definition in figure. Here parabola is given. As per definition, parabola is a locus of point which move in a plane so that the ratio of its distance from fixed point to fixed straight line is constant and equal to 1. So this ratio constant at any position of the curve. Next, let us understand hyperbola. Hyperbola is a locus of point which move in a plane so that the ratio of its distance from fixed point to fixed straight line is constant and greater than 1. Here the ratio is called eccentricity and in case of hyperbola, eccentricity E is equal to greater than 1. So let us understand this definition in figure. Here hyperbola is given. It is a locus of point which move in a plane so that the ratio of its distance from fixed point to fixed straight line is constant and greater than 1. So here this ratio constant and greater than 1 at any position on the curve. So here one conclusion is given regarding to eccentricity. In ellipse, eccentricity E is equal to Vf upon Vr which is less than 1 and Vf less than Vr. In parabola, Vf upon Vr is equal to 1 and the distance of Vf is equal to Vr. In hyperbola, E is equal to Vf upon Vr is greater than 1 and the distance of Vf is greater than Vr. Next, let us understand ellipse by directrix focus method. Example given here, construct an ellipse when the distance of the locus from the directrix is equal to 50 mm and eccentricity is 2 by 3. Draw the tangent and normal to the ellipse at given point. First, list out given data. Eccentricity E is equal to given 2 by 3 and distance of the focus from the directrix is F1 R1 is equal to 50 mm. Now ellipse is a closed figure. So ellipse having 2 focus point, 2 vertex point and 2 directrix point. So as per given data, first draw vertical directrix. You can take size any one. Next draw horizontal axis which is perpendicular to directrix. Mark R1 point on this directrix. Now distance of R1 and F1 point is given 50 mm. So locate F1 point on axis and take distance between F1 and R1 point is 50 mm or 5 cm. Now next, how to find vertex V1 point. Here eccentricity E is given 2 by 3 and we know that E is equal to V1 F1 upon V1 R1 is equal to 2 by 3. So divide this 5 centimeter length in total 5 parts because eccentricity is given 2 by 3. So here one part is equal to 1 centimeter. So take 2 parts distance for V1 F1 and 3 part distance for V1 R1. So locate V1 point, take distance of V1 point from F1 is equal to 20 mm and from R1 is equal to 30 mm and total distance in between R1 and F1 is given 50 mm. Next draw vertical line which is perpendicular to axis from V1 point. Next draw quarter arc, take center V1, radius V1 F1 and draw one arc up to this line. Mark here Q1 point, connect R1 Q1. Now R1 Q1 line makes angle which is less than 45. Next draw 45 degree angle line from F1 point which is intersect at one point on this theta degree angle line. From this intersecting point, draw downward straight line up to axis. This point indicate V2 vertex point. Now from V2 vertex point, locate F2 and R2 point as per eccentricity E 2 by 3. So locate F2 point and take distance of V2 and F2 is equal to 20 mm. Locate R2 point, take distance of V2 and R2 is 30 mm and from R2 point draw directrix. Next, divide this V1 V2 line into equal 8 parts and mark here division points as 1, 2, 3, 4, 5, 6, 7. Next, draw vertical line which is passing through all division points of V1 V2 line. Next, mark points on this theta degree angle line as A, B, C, D, E, F, G. Now, for finding locus point of ellipse, first take radius 1A, center F1 and cut 2 arcs on this 1A vertical line. One is above axis and another is below axis. Next, take radius 2B, center F1 and cut two arcs on this 2B vertical line. One is above the axis and another is below the axis. Similarly, take radius 3C and cut two arcs on this vertical line. One is above the axis and another is below the axis. Similarly, next take radius 4D, center F1 and cut two arcs on 4D vertical line. Next radius take 5E, center F1 and cut two arcs on 5E vertical line. Similarly, cut two arcs on 6F vertical line and 7G vertical line. Mark here locus point as P1, P1 dash, P2, P2 dash, P3, P3 dash, P4, P4 dash, P5, P5 dash, P6, P6 dash, P7 and P7 dash. Join these all points in proper sequence freehandly in form of curve. Here, ellipse passing through two vertex point V1, V2. Now for normal tangent, select one point S on the curve anywhere. Join this S point with focus point F1. Draw 90-degree angle line from F1 point up to directrix. Here mark T point. Now TF1 line is perpendicular to SF1. Join TS point, which is indicate tangent, and draw the normal line passing through S point and perpendicular to tangent. So this is the ellipse by directrix focus method. Next, let us understand parabola by directrix focus method. Example given here, construct a parabola with distance between focus and directrix is 40 mm. Now, as per previous theory, we know that eccentricity E is equal to 1 in case of parabola. Here, first list out given data. As per given data, distance between focus and directrix is given 40 mm. Eccentricity E in case of parabola is equal to VF upon VR is equal to 1. So, VF is equal to 20 mm and VR is equal to 20 mm. Because in parabola, the distance between vertex to focus and vertex to directrix are same. First draw vertical directrix. Next draw horizontal axis which is perpendicular to directrix. Mark R point on directrix. Next mark V point. Distance between RV is equal to 20 mm. Mark F point. Distance between VF is also 20 mm because in parabola eccentricity E is equal to VF upon VR is equal to 1 and total distance between focus and directrix is given 40. So distance between VF is equal to VR is equal to 20 mm. Next draw vertical line from V point. Next take center V, radius VF and draw arc up to this vertical line. Mark here Q point. Connect RQ points. Now the angle between this RQ line is always 45. Next, take division on this axis line from V point. Now, in directrix focus method, we can take equal or unequal division. Here I have taken 7 division and mark here division points as 1, 2, 3, 4, 5, 6, 7. Next, draw vertical line passing through all division points up to this theta degree angle line. Mark here points as A, B, C, D, E, F, G. Now for finding locus point, first take radius 1A, center F and cut 2 arcs on this 1A line. One is above the axis and another is below the axis. Similarly, take radius 2B, center F and cut 2 arcs on 2B vertical line. Next, take radius 3C, center F and cut 2 arcs on 3C line. Next, take radius 4D, center F and cut 2 arcs on 4D vertical line. Next, take radius 5E, center F and cut 2 arcs on 5E line. Similarly, cut 2 arcs on 6F and 7G line. Next, mark locus point as P1, P1 dash, P2, P2 dash, P3, P3 dash, P4, P4 dash, P5, P5 dash, P6, P6 dash, P7 and P7 dash. Next, connect this all locus point in form of curve freehandly. For normal tangent, select one point S on the curve anywhere. Join this point with focus point F. Next, draw 90 degree angle line of this SF line from F point up to directrix. Mark here T point. Connect TS point, which is indicate tangent. Next, draw normal line passing through S point and perpendicular to tangent. So, this is the parabola by directrix focus method. Next, let us understand hyperbola by directrix focus method. Example is given here. Draw a hyperbola having eccentricity 8 by 5, the vertex V of which is at a distance of 25 mm from the directrix AB. Find the distance of the focus F from the directrix. First, list out given data. Here, eccentricity E is equal to VF upon VR is equal to given 8 by 5. Distance of vertex point from directrix VR is given 25 mm. So, VF is equal to 8 by 5 into VR and the distance of VR is equal to 25. So, the distance between VF is equal to 40 mm. First, draw vertical directrix. Next, draw horizontal axis which is perpendicular to directrix. At intersecting point of directrix and axis, mark R point. Next, mark V point. Distance between directrix to vertex is given 25 mm or 2.5 cm. Next, mark focus point. Distance between vertex to focus point is 40 mm or 4 cm. Next, draw vertical line from vertex point. Take center V radius VF and draw quarter arc up to this vertical line. Mark here Q point. Connect RQ. Now the angle made by RQ line is always greater than 45. Next, take 3 equal or unequal division on axis from V point and mark here division points as 1, 2, 3. Next, draw vertical line passing through this all division up to this theta degree angle line. Mark here points as A, B, C. Next, for finding locus point. Now here for finding locus point, the drawing steps are common of ellipse, parabola and hyperbola. First, take radius 1A, center F and cut 2 arc on 1A vertical line. Next, take radius 2B, center F and cut 2 arc on 2B vertical line. Next, take radius 3C, center F and cut 2 arc on 3C vertical line. Mark here locus point as P1, P1 dash, P2, P2 dash, P3, P3 dash. Join this all locus point in form of curve. So this is hyperbola which is passing through vertex point V. Now for normal tangent, select one point S on the curve anywhere. S point join with focus point F. Draw 90 degree angle line from focus point up to directrix. Mark here T point. Connect TS point which is indicate tangent. Next, draw normal line which is passing through S point and perpendicular to tangent. So, this is the end of this session. See you soon in next coming video lecture. Thank you.